Hello, Mr. Melo here, your online math teacher, and welcome to my channel. Today we're going to be continuing my series on graphing functions. And if you find this video helpful, please consider smashing the like button, subscribing, and checking out other videos. So, transformations of functions. It's one thing we like doing in math is taking something that's more complicated and using something easier we're more familiar with to get to that more complicated thing, especially in graphs. So you want to be familiar with graphs like x squared, x cubed, 1 over x, absolute value of x, square root of x, 1 over x. Lots of different types of base functions, logarithms. And you'll use those base functions to graph more complicated versions of those functions. And we can graph them using transformations. And there's a few types of transformations we want to know. So translations is the first thing. And what that means is really shifting your graph to the left or the right, so horizontally, or vertically, so up and down. Now, the way we get a horizontal transformational function is by adding or subtracting values from x inside our function, just like I have here. And the way I remember it is when you are subtracting something off of x inside, that means you're going to shift it to the right or in the positive direction. So the opposite of what the sign. If you're adding a number, then it is going to shift to the left by that number of units. So when you add a positive number, it's shifting in the negative direction. When you subtract a positive number, it's going to shift in the positive direction, the opposite of what you think it should do. The other type of translation is vertical, so shifting up and down, and it's a little more straightforward. That's just tacking on and adding something after my function. And if I subtract something, it'll shift my function down by that many units, and if I add something, it'll shift it up by that many units. So we can actually see this in action with the graph x cubed. So I made this little thing in Desmos, and I set up these sliders here. So my C and my D are playing those roles of shifting left, right, or up, down. So I'm going to mess with C first. So we can see that if I start adding positive numbers, it's shifting my graph to the left. And if I were to subtract off numbers inside, it's going to shift to the right. Then similarly, if I start shifting my D, when I add numbers, it's shifting my graph up. And when I subtract numbers, it shifts my graph down. So these are our translations. So translation is just really a fancy word for shifting your graph to the left, right, or up, down. The next type of transformation we can do is stretches and shrinks. And there's two types, and these are a little more complicated. So horizontal. If I have a number 1 divided by c that I'm multiplying an x by inside of my function, that means I'm going to stretch or shrink my function horizontally by a factor of c. So what that means is that you will want to multiply the x coordinates by c. So if we had a transformation like this and xy was a point on our original graph, that point would move to c times x and then y. Vertical shifts deal with when that c is out in front of our function and not inside, and that's going to be a stretch or shrink vertically by a factor of c. And again, this time instead of changing the x coordinate, since it's vertical, we're going to be changing the y coordinate. So we want to multiply the y coordinate by c. So if xy is a point on your function, then it is going to move to xcy. And you could do a similar notation up here as well. So you can write a similar thing up here. And notice you can really see, once I emphasize it with this, that when you subtract inside, it's really a shift in the positive direction. And when you add inside here, it's really a shift in the negative direction. So, stretches and shrinks, a little more complicated than translations. not too bad. The one thing I will recommend, if you can, avoid having to do both horizontal and vertical stretches and shrinks in the same problem. You can usually algebraically rewrite your equation to only need to do one. If you could do that, I would recommend it. It will make your problem a lot easier. And we can see that in our Desmos tutorial also. If I'm changing a out in front of my whole function, that means I'm going to be stretching it vertically. So imagine that my graph has string and I'm pulling on it. It's like I'm pulling it up when I make it big, and I push it down when I make it small, so less than 1. And with b there, 1 divided by b, when b is big in the denominator there, it's like I'm pulling my string to the left and to the right. And when b is small, so less than 1, it's like I'm pushing it in. So here, that's how we can think of our stretches. Now, the last type of thing we have is our reflections. And really, I have 3 listed here, but you really need to only know 2. The reflection across the x-axis, which is when you have a negative out in front of your function. So that means you're going to take a point xy, and since it's reflected over the x-axis, it's going to move to x negative y. And our reflection across the y-axis when the negative's inside our function. So you would take a point xy that's on our original function, and it's going to move to negative x, y. And then this third thing listed is just reflecting through the origin. I just think of that as you're reflecting over both axes. So that point xy is really moving to negative x, negative y. So really you want to focus on 1 and 2. And I will make a note, these reflections do get a little more complicated when you start adding in the other translations. And we'll see some in the examples what I mean by that exactly. And we can see this exact same thing in this Desmos tutorial here as well. If I choose to, instead of having a be positive, make a be a negative number, we see it's flipping over the x-axis. So you can imagine that there. So if I go to negative 1, it literally looks like I flipped it over the x-axis. Similarly, with our value of b here, if I make that negative, it's also flipping it over the y-axis. So stretches, shrinks, translations left, right, up, down, and flipping over these axes are things we can do. Now, let's look at what a problem would be if we actually want to graph a function. So let's start out with a little bit more straightforward function. Let's start out by graphing a transformation of the absolute value function. So when you want to go graph these, the first thing you should always do is identify the base function that you're transforming, so that easier one you know a little bit about, and some nice points on that function that you plan to translate. So the base function's absolute value of x, and I drew a couple of nice points on that absolute value function in blue here. Now, what you always want to do when you're going to transform these, make a step-by-step list of the order you're going to carry out the transformations. And I always tell my students, try to work inside out. Do the innermost transformations first, and then work your way out. So the innermost thing here is what's closest to x, and that's the -2, our translation to the left/right. And since it's a -2, it's going to be a translation to the right in the positive direction. So step 1 is to shift everything to the right 2 points to the right 2 units. Now, here's where I said that reflection gets a little bit more tricky. That negative in front of those parentheses tells me, okay, I'm going to have some sort of reflection. But because I shifted to the right 2 units, and this is inside our function, meaning up here I said it was a reflection over the y-axis, I'm changing the axis I'm going to reflect it over. I am now going to reflect it over the line x is equal to 2. So our horizontal shift is going to decide what we have to reflect over. Since I shifted 2 units in the positive direction to the right, x equal to 2 is what I'm going to reflect it over. And then the final step, the outermost thing that you always deal with last, is your vertical shift up and down. And since we have a -1 here, it's going to be shifting down 1 unit. And once you've made your list here, what we can do is now just follow that step-by-step list for each point. So I'm going to start with the most unique point on this graph, and that's where the point is in our absolute value symbol. So I'm going to start here, and it says shift 2 units to the right, 1, 2, reflect over x is equal to 2. Well, I'm on that line here, so that would be this line up and down. So I don't need to move it anywhere. And then shift down 1 unit, and that's going to move my point there. I'll do this point next. Shift 2 units to the right, 1, 2. Reflect over the line x is equal to 2. So that line x is equal to 2 is this dotted line right here. So that means it's now going to flip over it to here and then down 1 unit. Same thing here. 2 units to the right. Reflect it over that line x is equal to 2 and then down 1 unit. And you keep applying these to our points on each side of the graph until you see this picture. And we know how our graph is going to continue. So we get a nice picture. Another thing you can use to help check your work is the domain and range. So if you know there's bad points in your domain, but then you see points there on your function, the graph of your function, you know you've made an error. In this case, we know the domain is all real numbers for the absolute value function, so it doesn't matter how I transform it with these basic transformations, it'll be good. But the range, I do know I've just shifted everything down 1 unit, so I pick up a little bit more in our range. Our range now goes from -1 to infinity. So this is one transformation of a function. Now, let's look at one more example, and this time, let's look at a transformation of a rational function. And this graph's going to have a lot more going on in it. So you can see that I have a lot of things going on with this transformation. But the idea is still the same thing. Start out, identify your base function. And since it's a constant in the top and just an x in the bottom, its base function is just 1 over x. Now, I mentioned earlier, if you can, avoid doing vertical and horizontal stretches and shrinks at the same time. Right now, this graph would be set up to have to do both because I have a 2 up top, so that's like multiplying it out front, and that -1/2 in front of our x plus 1 factor. So what I'm actually going to do, I'm just going to rewrite that fraction by multiplying the numerator and denominator by -2. And when you do that, you end up with -4 over x plus 1 minus 3. So this is going to be easier to graph. And if you want, you can actually think of me pulling this -4 out in front. So it's really emphasizing that now I've just written this in terms of a vertical stretch/shrink, which is going to make our lives easier. But now once you've done that, go and make a list of the transformations. So I recommend try pausing this video, see if you can write the list. Okay? Hopefully you paused the video and tried writing the list. If you did, you hopefully wrote the following. So working inside out, the innermost thing is this +1, so a shift to the left of 1 unit. Then we move out to our 4, so it's a stretch vertically by a factor of 4, so that means we're going to multiply y coordinates of points by a 4. But it's a negative, so that means we have a reflection over the x-axis. And then finally, we have our -3 out here, so a shift vertically down by 3 units. So making this list will help keep yourself in a good pattern. Now, with a graph like base function like 1 over x, where you know you have asymptotes at x is equal to 0 and y is equal to 0, I always recommend transform your asymptotes first. That will help you get a rough idea on where your picture is going to lie. So if I transform those asymptotes, which I already knew existed, and say I move the y is equal to 0 asymptote, if I shift that to the left, it just keeps the line on top of itself. I can't stretch vertically, since y is equal to 0 is the same thing as multiplying 0 by 4, so it doesn't go anywhere. I can't reflect it over the x-axis because it is the x-axis right now. And then shifting it down 3 units. So the only part of our transformation that moves the horizontal axis is the shifting down of 3 units. So y is equal to -3 is our new horizontal axis, or horizontal asymptote, and the vertical asymptote, shifting to the left 1 unit would move it. It's the whole thing to the left. Stretching it vertically won't do anything because it's like a string that's standing straight up and down already. I'm just pulling it more. Reflecting it over the x-axis just reflects it back on itself. And then shifting it down, again, just shifts it onto itself. So we know our new vertical asymptote is going to be here at x is equal to -1. And this already gives us a really good idea on roughly where our picture is going to lie. The next thing you need to do is just move a couple of your nice points. And the nice points I use typically for my rational functions are 3 points up in this first quadrant, so 1, 1, 1/2, 2, and 2, 1/2, and 3 points in that third quadrant, -1, -1, -2, -1/2, and -1/2, -2. So try pausing this video, see if you can move those points along with the transformation. Okay, hopefully you did, and once you moved those points in that first quadrant, you should have gotten a picture that looks roughly like this. So one of our points actually went off the graph, but you can see roughly where the graph is now. And then if you transformed the third quadrant blue points, you should have gotten this picture. So, and again, you can always use domain and range to do things. Everything is in the domain of our new transform function except the value of -1. So you could write a domain of -infinity to -1, union -1 to infinity, and range. Everything is in the range except for this, our asymptote here, y is equal to 3. So for the range, you could write -infinity to -3, not 1, union -3 to infinity. So, this is an example of our transformations. Now, tips I always have in mind, so keep these in mind when you're transforming them. Always identify the base function first and know a few nice points that you'll transform, just like I did up there. Make a step-by-step list of these transformations in order that you will be applying them to the base function. So think work inside out. Always transform asymptotes and other unique features of your graph first, because this will help you identify if you're making mistakes later if it doesn't seem like they're matching up very well. Use domain and range to help check for mistakes. This is another way you can kind of see if I've made mistakes. And then lastly, when possible, use algebra to avoid doing both horizontal and vertical stretches and shrinks. I personally tend to try to rewrite them so I only have to do vertical stretches and shrinks. But your teacher and you might prefer something different. So, I hope you found this video helpful. It's a little longer than I normally like these videos, but this is a pretty big topic and I want to get into it thoroughly. So if you found this useful, hit the like button, subscribe, check out my other videos, and have an awesome day.